Welcome to the development team update from the Tau team. My name is Fola, and I'm going to pass it over to Karim for his overview this May.
Thank you, Fola. This month, Andre continued his work on the Agoras live application. He added support for multiple areas of interest per user, which is a very major feature, allowing publishers to have multiple areas of interest, such as, say, you could be at the same time a lawyer, a tennis coach, and a cook, for example. And each one of those areas of interest, for example, would carry a different rate with it and a different ratings and everything. So that's a big change. But he also continued further testing on the rest of the application and fixed a few bugs and general usability issues. And he's going to show us a demo as usual later on. Luca continued the integration of the Z3 solver into the TML optimizer. We're thinking of splitting TML into two runtimes, basically a compiler, an optimizer compiler, and a runtime. It's a major architectural change, but we're considering that. We haven't made the final decision on that yet. Perhaps Ohad will talk about that. So Z3 is a big part of that optimization steps, because it has given us a lot of performance improvements in terms of query subsumption. And we reviewed Luca's code, and it was super excellent for somebody of his level of experience. We're very happy with that. And he's getting ready to integrate that into the main code base. Maurici continued his work as well on TML optimizations. He helped Luca integrate with the integration of the Z3 solver, but also he's identified several other avenues of optimization. For example, he improved the hashing algorithms for BDD, because we found out that our existing hashing algorithm was not good enough. So by making that improvements, we got some very general improvement in performance in TML just by improving the BDD hashing algorithms. He also identified the fact that even within a certain rule, the ordering of the rules within the body makes a big difference in the TML performance. And so he continues his work on TML optimization, which is for us really the main line of work right now. Juan also continued refactoring the tables with an eye on potentially splitting the execution and the compilation aspects or steps that I talked about earlier. He's also in the process of redesigning the arithmetic built-ins, as well as the built-ins for the log-based 2 and the summation. He also continued working on second order logic. He's going to tell us more about it in his segment. Tomash has been working on implementing, I think like we mentioned last time, an implementation of Sudoku puzzle in TML. And based on that work, basically that unveiled, he had to implement or change the modification or modify the count built-in to remove any algorithms, so we can count facts without necessarily knowing anything about them. And so that was part of the Sudoku implementation. It also revealed several issues or bugs in TML that he managed to fix as well. So I mean, that's the whole purpose of doing these demos, is to uncover needs for real applications. And then finally, Professor Luc Sol, who actually, he just joined us a month ago, so he's still quickly coming up to speed on the TML code base. But Ohad had him, as usual, implement his own BDD implementation, which he did fairly quickly, and we all reviewed it, and it looks really good. So that's in a nutshell. Then we'll let everybody go into more detail as usual. Thank you.
Thank you very much, Karim. I'm going to pass it over to Professor Benzbullah. for his overview and update this month.
Yeah, thank you very much. Yeah, I mentioned earlier in the question and answering section already that I have been working as one line of focus work this month on the experiments, on Isabel-driven experiments on a layered approach to work with the law. They were quite successful. I was actually able to simplify the ideas I had here, pretty much use even kind of very simple controlled natural language with some illustrating examples, and showed that basically it would be possible to take, when we would decide to go for such a layered approach, which is not let's say the preferred solution at the moment, but it would be an alternative. And then we could start with a layer in which the law is controlled, so the law is formalized, and a layer above in which we can talk about rules of changing the law, and then a third layer in which these rules are governed. Such a layered approach should be relatively straightforward to go for, but it wouldn't give us the entire ultimate goal of talking about a law of changing the law in the law itself, which is still the ultimate goal on the table. But that was an interesting line of research, and created this alternative view for the project eventually. There are other experiments I went for instance, with automated tune provers, also in connection with OHAD, for example. Now, just recently, we looked into experiments with Boolean algebras and see how they perform. The questions are on the table about decidability of these problems. And at the third line of activities, I'm actually working on a draft paper for model finder, or combined tune proving and model finder approach for the project, and developing their kind of new ideas, which are combined with, let's say, the experience from previous projects I have. These are the three main lines of activities in the last month there.
Now I'm going to pass it over to Luca for his update this month.
Thank you, Fola. Hello, everyone. Karim already said almost everything I did, but let me say it in my own terms. So I started the month exploring the V3 API for the C++ language. Fortunately, there's a huge, or not huge, but big example file on the Git for Z3 showing examples how to use it. And from that, I learned my way to handle the API. From there, I continued integrating Z3 into TML so that we can use it in our project. So there was a little bit of try and error going on, but no, it works fine. And then after this worked, I started an implementation of query containment. We already had that with Maurice's work. So the different route now takes a query, encodes it as a logical formula, and then we can use Z3 in order to check whether two rules converted to logical formulas imply each other or not. And if they do, we know one rule is contained in another. And with this mechanism, we can now move to existing optimization algorithms, which Maurice already implemented, and incorporate this new functions to check between containment between two rules in these optimizations. And we should see a speed up in the system. And another thing that is left for the next month is also to see whether this will cause a speed up in all instances of problems, or whether we have to do some more careful treatment in general. So this is an outline for the next month already. But yeah, that's it from me. Thank you.
Thank you very much, Luca. What I'm going to do is I'm going to pass it over to Professor Franconi for his overview and update this month.
Hi, everybody. So I guess this has been a very interesting month. Discussions are going on the idea that the flexibility of the language to express tau should be able to capture the notion of self-reference. So basically, we have to be able to write rules that are able to modify themselves, or be able to check whether themselves are true or not, and then decide the course of action. So this notion of self-reference is in logic quite important. It easily leads to well-known paradoxes, and so we are discussing, first of all, the use case that in Tau should be relevant for applying this kind of reasoning. And then we are trying to understand if there is a general way to capture this phenomena in a logic that would be also feasible in practice, but very expressive in doing what is needed to be done. I found these ideas quite challenging, but it's really along the lines of the dream of Ohad and IDNI as a whole. So the idea to build this system that evolves in exactly the way the user wants it to evolve, including the possibility to change the rules that govern the evolution of Tau itself. So I think it's an interesting idea, and from the research point of view, the foundational point of view, it's rather novel, and the kind of solution we are working on as a team of scientists is quite non-trivial, but we are working on it. Okay, let's hope that this work goes on. Okay, thank you. That's the update. Bye-bye.
Thank you very much, Professor Franconi. Now I'm going to pass it over to Tomash for his update this month.
Hi, everyone. So this month, I've been trying to implement various algorithms for solving combinatoric problems in TML, for example, Sudoku or Latin square. I've revised the count built-in. I've removed its input argument because it isn't needed and it is causing confusion. Count built-in simply returns number of results of the query, of an alt query in the rule. I was considering to create built-ins for counting only filtered records in a table and another built-in for processing records in a table one by one. But I've managed to do it with the current TML features without adding anything new. And I'm also testing and debugging TML. I found the bug in a variable alignment for first order formulas, and I've also found a performance difference between inequality when using inequality in first order formulas and inequality outside of first order formulas, which is suspicious. So that's all from me just now.
And now I'm going to pass it over to Umar.
Hi team. Mostly this work has been on improving the algorithm for type checking and type inference. So now we have a fixed point based iterative type inference algorithm. So it required changes at different places. Using these infer types and static types, we can now convert arithmetic terms, equality and less than equal terms also into the bit size to universe. So most of the testing is still underway. It would take time to get the final feature complete on this. Also, I added some tests and made these changes in the master branch. Thank you.
Thank you very much, Umar. Very good. Now I'm going to pass it over to Andre for his update this month.
Hello, everyone. Last month, I continued testing Agoras Live. Also, I've implemented necessary improvements over the user experience on Agoras Live. First of all, the small thing, the infinite scroll here was not working. Now it's working. Some minor fixes also here on the UI, but let's go into more significant changes. Now you have if you present yourself in several fields, for example, aerobics, robotics, and blockchain, you now must describe it more detailed. What exactly do you plan to share? What knowledge do you plan to share? Also, you will have to provide a rate for each of the topics, because, for example, you can speak, I don't know, for free about dogs, but about blockchain, you want to speak only for some money. This is one change, and the other change, I completely remade my sessions in the profile. Now it's the one place to manage all your sessions and all your appointments. Here you have your calendar, of course. Here you have all unconfirmed calls. You can here confirm it. And now in confirmed calls, for example, you have a session person, and if you want to cancel the confirmed call, now you have to provide a reason why do you want to cancel, and the other part will get a notification on the email about the reason why you cancel it. And also it has a view for your finished calls and also separate view for grab sessions. And that's pretty much it for this month. Next month I will finish grab sessions to be in my calls view to be more detailed about participants, because as a teacher you want to know who is going to attend to your class. And I will finish this important thing on profile, where you must set separate rate and description where you add topics you want to discuss, you can share knowledge on. Thank you everyone. Bye.
Really cool. All right, I'm going to pass it over to Maurici for his update this month.
Thank you, Fola. So this month I identified rule body ordering as a major factor in TMR performance, alongside variable count and ordering. So essentially I had two programs just did the same thing, but their performance was differing remarkably. And when I started playing around with the rule orders and evaluating and changing when each body of a rule is evaluated, I noticed that it causes significant performance increases. And I think it's because depending on the body ordering of a rule, it changes the sizes of intermediate BDDs during the computation. So yeah, that was a major realization for me. So now I know that body ordering, in addition to variable count, and variable ordering is important for TMR performance, and it's something which we need to pay attention to. Alongside this, I also realized that if body ordering is important, I realized that that body ordering was important by manually changing the rule body orders. I realized that you could turn this into an optimization, and that you could have an optimization which measures how much time each body takes and moves and permutes the body ordering depending on the runtime information. So it's something which I'm planning to do, but it's not something which I've prioritized yet, because that this sort of optimization would only improve longer running programs where there's actually time to figure out what body is actually slow. Another thing that I've done is that I wrote a parser generator, which takes TMR grammars and produces parsers in data log-like languages. So yes, it produces a parser in TMR, but I also got it to produce a parser in Prolog. And the reason why was that I just wanted to gauge the performance of the TMR grammar in other similar data log-like languages. I haven't yet found any other strictly data log-like languages. I've only found Prolog so far. So TMR takes about 3.7 seconds to parse itself, and Prolog takes about 1 second to parse TMR. Although this data really isn't that important, because Prolog is backward chaining, whereas TMR is forward chaining. So I really need to compare TMR's performance to other forward chaining data log-like languages, which is what I hope to do, and I've got a framework for doing that. So maybe next month I'll be doing this. I also just helped out Luca with the CQC engine, just introducing him to the existing code base, and also just participating in the code reviews for his Z3 integration, and also testing his code to uncover if there are any potential bugs. One thing which I investigated, which was essentially total failure, was I implemented a top-down parser for TML in TML, and as you would expect from a top-down parser, it produced far less productions. It produced 5% of the productions of the present bottom-up parser that we have. But unfortunately, it didn't improve performance. So while it cut down the number of productions to 5% of its former value, it was now taking 5 times longer. So obviously, reducing productions doesn't necessarily correspond to a speed increase in a parser within data log. And the last thing which I did was I designed and implemented a backward chaining interpreter for pdatalog with support for built-ins. So TML is presently forward chaining, which means that it starts off with an initial database and it elaborates upon that database. Whereas with backward chaining, it starts off with the goal and it figures out whether that goal can be reached from an initial database. It figures out whether that rule it figures out what conditions are necessary for that goal to be reached. So I implemented that for pdatalog, and we know that pdatalog is equivalent to TML. So that was an encouraging result. And recently, I think yesterday, I've also realized how you can implement a backward chaining interpreter for TML now. So I hope to get into that more next month. So yes, that's my progress for this month. Thanks.
Brilliant stuff. Now I'm going to pass it over to Juan for his update this month.
Thank you, Fola. So yes, as Karim already put into advance, I've been, this month is really, my focus has been really into TML code-based, TML core. One major step that I is close to be committing to the code base is the, let's say, the bisection of the tables class, which has been incorporating many transforms and features that are possibly not are not related to the actual main purpose of tables class. So that's very aligned to the proposed split between compiler or transformed binary versus our dynamic environment or virtual environment to execute or to compute TML programs. So this really in that direction, and also to simplify the TML class to keep analyzing its design and looking forward to reach the better, well, to optimize its performance. On this regard, what both things that Ulysses commented about these body orderings, and also what Tomash has pointed out as a limitation of the first order formulas feature, plus some different performance difference there. I've been really analyzing variable orderings and how we assemble the BDDs with regard to the rules, plus the first order formulas, looking forward to minimize the number of permutations that we need to do there. That's possibly the major cause why Maurici found out that body ordering impacts on performance, because we may save or add more permutations to the BDDs involved in those bodies. And what Tomash was pointing out is that current first order formulas, they are not designed to handle constants on the heads. So that's something that I walked to one path still, but I sort of abandon it because whenever I start embedding the constants of the heads as part of the BDDs that are involved in the formula, we sort of enter into a performance penalty there that we don't want to deal with. So basically, my focus is very on the deep internals of TML, which bond the rules and the formulas to with the BDDs, which of course involve variables, variable maps, and variable orderings there, testing different approaches in order to give TML. So redesign some part of it, looking forward to gain performance and to wrap up several functionalities that we have in there. Being specific, the functionalities that we're looking for, and in my case, I'm looking forward to wrap up there. It's a redesign of the arithmetic feature with everything as a built-in, which is also aligned with Tomash work on built-ins. To provide new arithmetic built-ins for logarithms and summations. And of course, any variable related design has impact on the early second order feature that I have been mentioning for several updates already, but it's still there to be wrapped up as well. So really deep work into TML's core design, and that should be my focus for the coming month and possibly several months ahead. So thank you.
Thank you very much, Juan. That's excellent work there. What I'm going to do is I'm going to pass it over to Ahad.
This month I worked on our ongoing quest of finding a language that has self-reference, that is able to reason about itself about consistency of sentences in the same language in a self-referential way. And I made some significant progress. I discovered some new ideas from Boolean algebra and started implementing them. So soon we will have a solver for this logic, and we will see where it takes us. And that's all.
Brilliant. And that is all for us for May 2021. So we'll see you in Telegram. If you have any questions, please drop it in the next Q&A on the next Q&A form. And yeah, thank you very much. Cheers.